This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
All right. Okay. Let's get started. My voice is very weak today, so hopefully it will survive the rest of the lecture. So today I want to talk particularly about your task for this week and your report, because that's a large component of the assessment for this subject. Now, I'm going to, so this is the outline for today. It's going to be fairly sort of off the cuff. I'm going to give examples and talk about what to do and what not to do. So the outline is, I'm going to talk about workshops this week, what will be happening. I'll give you some more details about the order of how things are going to go, what you can and can't do. And then I'll talk about the assessment. And the assessment involves the workshop this week, obviously, and the final report. Now, for those of you who have looked at the final report rubric, it's actually pretty similar to the capstone project rubric. Now, embedded systems is a prerequisite for the capstone, so it's good that you're going to have some experience with writing a report that conforms to the capstone report marking process. Okay, so did anyone make it to the sessions on the weekend? Yes? Would anyone like to give me some feedback about how they were managed or how they ran? Yeah? Can you give me some more details? This is the first time I've ever run anything on a weekend. It was only decided because the weekly ones were overflowing. So let me know.
We sent email for 12 o'clock on Sunday.
Yep.
All three of us.
Yes.
And she didn't receive the email. And she said to one of our friends saying, oh, you didn't follow Gavin's thing. So quickly sign up for the 4 p.m. one.
So did you still get into the 4 p.m?
So we got in the 4 p.m.
Let me just turn off the mic. Hang on. Okay, so today I'll talk about all sorts of weird stuff going on here. All right, so we're going to talk about the process for what happens in the workshops next week, and then I'm going to talk about report, how to write a good report, and also give you examples of previous capstone projects which I've had, which have had bad reports, and I'll highlight the good and bad parts of those reports. So let me just pull up the specs. Oh dear. So, okay. Right, so here are the specs for what you'll be doing in the workshops. So I'm sure you've all read that massive amount of text there under the design requirements. What's more important is the actual mechanics of on the day this week. So there will be 3 or 4 permutations of where these objects are placed on the course. The course is such that it is rectangular, then it angles inwards, so your robots can basically find their way to the ramp, flat and descending ramp section. That's what these segments represent here. So you can bounce off this to get there. That's the idea. There is sufficient gap. I know this is not to scale this picture, but there is, again, sufficient gap for the kabuki to go either side of every obstacle. There are no T obstacles, and your robot should never have to backtrack. Okay, so even if you hit this one, if you make the decision of going left or right, you will still be able to go around it. Okay, if it was too close to this side and you turned left, you'd be in trouble, right? And that's, in my mind, that's not fair. That's a random decision, and that costs you going left in that case. Okay, so yes, there's 3 or 4 different permutations for these. Whichever you get on the day is what you get. The class gets the same for the whole class because we're not going to move the objects around. Okay, just again, I had questions about it again. There are no obstacles on any of the hill sections, ascend, descend or top. Okay, so in terms of how you, I'll talk about the mechanics of it again. Remember, if you're in the EDS 12 workshop, and EDS 12 is where the robots are stored, that you start later today. Okay, we're staggering you by an hour and a half for these concurrent classes in order to make sure that we have enough working kabuki, because it sounds like we've got some problems with that, but we should at least have 10. We only need 10 to test a class. Right, so just please remember which class you're in depending on the room. Some people are still confused about which one they're in. So what happens is you will get, basically, if you just sort of look at the timing breakdown here, you get 30 minutes to be allocated a robot to get the code on there, your code, and to have it running ready in a paused state. So your state machine should be in a paused state. Robot should be on and running with the code, with the code paused. Then, after that 30 minutes, everyone heads to their Mechatronics Project Lab. That's what MPL stands for. If you want to know where that room is, it's on the corner of Old Metallurgy. So it's on the western side of the building. Okay? Now, after that, after you head there, there are no computers in there to do any alteration of the code, and you're not to bring your own computer to do that. So the moment the class leaves the workshop room, no more alterations. Right? You shouldn't be working on it in the last minute. You should all bring everything, your demonstrators will tell you, but bring everything out of the room, all personal belongings as well. You're free to leave them in there, but it's very risky because there'll be no one in the actual workshop room. Everyone will be in MPL. Okay, so please pack up everything, bring all your valuables along, because you'll spend the entire remaining hour of the class in the MPL lab. Okay, so in terms of testing, selected at random. Now, I have told the demonstrators that if there are groups that are keen to get done first, you can volunteer. Otherwise, they'll just choose you at random. All right? Your robot gets placed in the ground orientation at the start line. There will be a piece of tape, and the robot has to be behind the piece of tape. So perhaps this is a bit misleading. There's no tape here, but there's a tape marker where the front of the robot shall be. Okay? Then, when the demonstrator lets you know, basically hit the go button to unpause your state machine to go into some sort of, motion part of the state machine, and they will start a timer at that stage. All right? So they'll probably say ready, set, go to make sure it's all good. Now, this is the most important stuff. You have 3 minutes to get through the course. If you interfere with the robot, you touch it or kick it or something like that or whatever, or try and remotely access it or something like that, it's over. If you break any of the rules, you fall off the side of the ramp, you hug something or you scrape against a barrier, whatever, the attempt is pulled. You successfully complete the course if you avoid all obstacles. I mean, avoid as in you detect them by hitting them. That's your only way of detecting them. But then get around them, go up and down the hill, and stop within 40 centimetres of the end. So this is our check that you actually have some sort of inclination detection on your robot. Okay? Otherwise, you could just do obstacle avoidance for the whole thing, right? And cliff edge sensing here. So detecting you've reached the bottom and stopping within 40 centimetres of that is what we're after. Okay, so that's telling us that you're doing proper hill climbing and descending. All right, so you have 180 seconds. Now, in terms of grading, so 2% of your mark will come down to, on the day, which of these things your robot gets through. So in terms of avoiding obstacles, going over the hill, stopping at the right location, being within the time frame. So you're graded on a spectrum, right? So if you just can avoid obstacles, then you're only going to get, 20% or something of the mark, right? It's graded like that, progressively. Okay, if you can do all things, you get 100%. All good. Then the report, which is 18%, contains, it's fairly free as to what you include in there, but you must include an FSM diagram of your robot algorithm. So we can see it without looking at tons of code, and we can see it from the top level of how it's supposed to work. Now, you're supposed to use all of the stuff we've covered in lectures. So if you're using extended state machines, put variables in there. If you use state refinements or hierarchical state machines, do that. If you have initial or history or preemptive transitions, things like that, put all those things in there as well. It should be in the exact semantics of how we have been doing state machines in the subject. Okay? We also want you to talk about the sensor data that you used. So all the sensor data that's available to the MyRio in terms of, what's the range, what's the format of the data, how you used it. And then this becomes more vague down here. So we want you to document the design procedure. I'll tell you a little bit about that when we talk about the report. how you tested it, how you validate it. Now, testing and validation are different things. Validation is typically a pen and paper exercise, whereas testing is normally a go and run the thing and then observe what you've seen. So the validation process includes either reliability or reachability analyses. I'm not telling you what to put there because it depends on your state machine, right? So for instance, I don't know, if you've got a hierarchical style state machine where you've got, say, paused and in motion, and in the in motion part you've got hill climb, obstacle avoidance, like that, right? Maybe you might want to show that something simple like a reachability analysis, or show that you could never be, you could never get from one of the motion states back to pause without a button being pushed, or something like that, right? Or you could never simultaneously be in the hill climb and the obstacle avoidance states, something like that. Okay, so I want you to think about what you think should be safety requirements, maybe a liveliness requirement, and test your state machine against that. So you can categorically say, you know, my machine won't do this or it will always do that. Yeah. I can't hear very well. I've got blocked ears, so.
Okay. If a validation is the paperwork, right? So what if our deployment, the deployment exercise, where should I put? Because I take the video and take the photos of them.
Testing.
Testing.
Simulation or screenshots, yes. Another thing we'd like to see, and I'll talk more about it in the report, is photos of stuff, right? We want to see you documenting things by, show a photo of you sitting at the computer, or show a photo of the kabuki or something like that, right? Because that's what you've been doing. Nothing's worse than a report that's just all words and doesn't have any visual representation in there. Okay, this is also important as well. So you have to talk about the outcome of the final run as well. If you weren't successful, don't lie. Put it in there. Say you weren't successful. We want to know why and maybe what you might want to do to improve it. And then I also want a discussion section, which is one of the most overlooked parts of a report, and it's also a significant component in the rubric, which talks about how you applied some of the techniques from the lectures to the project and what would you improve in the future. Yes?
So for the FSM diagram, if we've done it in LabVIEW, is that sufficient if we just take a screenshot, or do you want us to draw it out in full?
I'd like you to draw it out according to the semantics that we've used, yes. It's good practice for the exam, which you'll have to do similar things on the exam. Yeah?
I think a couple of weeks ago you mentioned there was a disconnect timer on the Kabuki, such that when you uploaded the program or whatever, it disconnects. So I'm
Yep.
wondering, if we went to the MLP room or whatever it is, how do you know that it's not going to disconnect and stop?
Okay, so your demonstrators have instructions to tell you what to do. There's a couple of ways around that. You can, when you execute your binary executable, you can put a special keyword in front of it, which basically keeps it alive. All right, they'll tell you how to do all that. All right, so it'll always stay alive. Now, just having said that, sorry, about the testing again, if there is a catastrophic failure, don't think that it's all or nothing. If there's a catastrophic failure or there's something beyond your control, there is an opportunity for you to redo the demonstration again, okay? That involves possibly reprogramming. So back to the time frame. So here you can see if everyone's back after an hour and a half, there's still potentially a little bit of time to go back to the MPL. So any groups that have some sort of failure that's not their fault, it's not a bad algorithm or something like that, the demonstrators will take on a per needs basis back to the MPL to get their testing done. Don't rely on that because it's up to demonstrators' discretion, and they're basically being told that it's only if the robot just switches off for no real reason or something, or if something fails, the battery stops or something. Right. Okay, so there is an opportunity to rerun things again. Okay, so the report again, 20 pages in length. So that's irrespective of group size. That's maximum. It doesn't have to be 20 pages, and that doesn't include any appendices. If you want to put lots of interesting stuff, but it's not that interesting that it should be in the body of the report, put it in an appendix. And I'll show you some examples of good and bad with that in a minute. And the marking rubrics up. So only one person has to submit. You submit via LMS and it's due on first day of exam period. Okay. Luckily, the embedded exam, if you've looked it up on the timetable, has anyone looked it up? When is it? Week 3, yeah. So there's plenty of time between the submission of this for you to study your other subjects and then sit in embedded exam. Late submissions, unless otherwise organised with me, are 10% per day penalised. Any questions on this stuff here? Yeah?
Do you have any recommendations on software for drawing FSM?
Good point. So I draw FSMs in LaTeX, which is disgusting to do. It takes hours. Paint is fine, right? Anything you can draw regular shapes and it looks okay, and the arrows look all right. All right?
Free online UML, sort of like free diagram drawing things on like just Google, like FSM UML.
Okay, yeah, Google FSM UML drawings, yeah. Yep, you could hand draw them and scan them in if you really wanted to, although that tends to look a bit average, to be honest, because the contrast looks all weird and stuff. Okay, any other questions? This is a big chunk of your assessment for the subject, obviously.
Do you want code in the index?
I'll show some examples of that in a tick. Okay, so on to the marking of the report. Okay. Right, so has everyone had a look at the rubric? Yes? Okay, this is the rubric. There are, what are there, 6 categories here and they're weighted differently. Now this is percentage of the 18% of the final mark of the subject. You'll get a mark out of 100 basically for the report and it's scaled down to out of 18. Okay, so there's only really 2 weightings. It's either 20% or 10%. 20% is on how your report looks. So you could write something that is absolute rubbish in terms of technical content, but it looks great and is well written, and you can get almost full 20% for that. Okay, then we talk about formulation of the project. So I want you to write about, to a non-embedded person, how you motivate the project. Okay, what were your goals? What were your outcomes? What did you set out to achieve? That's basically it. Don't just write, we had to do this because it was a project in the subject and the specs are already given to us on LMS. Okay, please try and elaborate a bit more and talk about your personal objectives for the project, right? What did you hope to get out of it? Then there's 10% on background material. Now, you can see all the different wordings in here. I won't go too much into detail about these, but background material is about the theory. Okay, so talking a bit about the theory behind some of the stuff you're going to be using, particularly if you're using sensor data, right? You might want to talk a bit about some of the sensor stuff that we've done. FSM stuff, you might really want to talk about FSM. How you code FSMs according to what we've done in the subject. Then you get the meaty section of the report. So these are kind of like little bits and pieces, and this typically could be one chapter of the report, a motivation and a bit of background. And that these are really almost standalone chapters, and they're consequently weighted more. So design development. So if you look at the descriptor for this one here, now a bit wonky. I'll just say that, note that This is as wonky as how I feel at the moment. So note that the descriptors here for 90 and above are blank, okay? Because just think we want, it's high distinction but better than that. I ran out of superlatives to put up there. So it has to exceed that, okay? So it's got to be, and it's got to be justifiable for that. So these are empty. So you should be aiming for this and above if you want to get in that top category. Now, back to here. So over here. Let's just look at the top descriptor here. So for your experimentation, simulation, testing, we want a thoroughly documented implementation process, okay? So talking from testing, from the final product, what you ended up with at the end, back to expected outcomes. So it's a nice link to show all your testing. You tested the obstacle avoidance in workshop, whatever. You tested the hill climb in workshop, whatever. They don't have to be aligned with what the real workshops were. Maybe you're a bit slow with some stuff and it happened later on. That's all good. You know, this is not a exercise in correctness of timing. This is about an outcome, an overall outcome. Evidence, that's very important too. I'll show examples of poor evidence and good evidence in a minute. And then it gets worse as you go down here, right? You have less simulation or testing documentation, that sort of stuff. This is where photos and stuff might help demonstrate you're testing something, right? It's a nice visual representation. Lastly, 20%. So a fifth of the report mark is action on reflection and conclusion. This is by far the most overlooked part of a report. Partially because, you know, you've slogged through everything here and you get to the end, it's like, oh, I'll just quickly just summarise what I've done. Not so. The reflection part is very important. So this is where you compare what you actually got to with your expected outcomes. Now that's all right. If your robot failed at the first hurdle, right, it got off the mark and it hit an obstacle and your code failed or something, that's okay. Tell us about it, right? And tell us perhaps some recommendations what you would do differently, or if you did a fantastic job, what else would you do? Would you put ultrasonic sensors on there or something so you wouldn't have to bump into objects? Maybe how would you do that? Is there a way of interfacing them, etc.? Okay? So creative, insightful recommendations, that's what we want to see here, but a good reflection about what you actually achieved. And this makes the report read like, it's almost like a circular thing. You set out your goals, you talk about how you did it, you show what you did, then you reflect on what you got with respect to the thing you motivated everything with. It's like a nice circular story. Okay? Now, down at the low end of town, down here, you can obviously see these are the poor components here. So no motivation, no structure. Especially if you're doing a group report, you have to have continuity of structure. No background material. Research. By research, I mean reference to lecture slides, reference to textbook, reference to external data sheets, that sort of stuff. That's research. Anything that involves looking up stuff is research. It has to be, and it has to be documented. When you do a capstone project, obviously you'll have to do a lot more research, right? What else? No evidence, no reflection. That's pretty straightforward. Ugh. All right. So what I'm going to do is I'm going to take you through some of my past students' capstone reports. Now I'm going to try and keep them anonymous because some of them aren't great. And maybe we can even mark them according to that rubric. So I have gone and picked a couple of interest. What would we like to start with, the good or the bad?
The good.
The good? Okay, we'll do the good. And then we can do the bad. So, give an example of the good here. And I won't import the students' names. Okay. So, you'll be able to tell which project this is, there's no problems, but this report was a good report. This was an H1 level report. So this was the an MUR team, okay, so the racing team, the car racing team. Right, so from several years back, so there should be no student data in there. Right, what's good about this report? Contents page, right? Good, that's what we want to see. It has a nice structure of... now, this was kind of split because the MUR team's weird. They kind of have different sub-teams within a team. But within these, you had an overview. They talked about the design procedure. Then eventually, they'll talk about testing later on, discussion section, future work. Notice that this is 8 pages of the report or thereabouts, and then a conclusion. Anything that's irrelevant gets included in the appendix. So they've also got a list of figures as well. Now, it looks like they did this in Word, so that whatever you want to use is fine. So motivation, that's super important, right? So I want you to, in, say, the first chapter, come up with an introduction and talk about a motivation. Even pose it as a question. Why would you want an autonomous robot? It's a good one, right? That's where references can come in nicely, okay? You want it to deliver a pizza or something or whatever. You want it to go into a war zone. You want it to rescue people. Great. Show some references for that, right? Why would you want to do something like this? Okay? Then perhaps talk about an overview of the project. If you can modularise it in any way, and the workshops were sort of modularised early on. So you learned about sensors, and then you learned about obstacle avoidance, and you learned about hill climb, that sort of structuring. Hey, what happened there? Oh, it's a very slow diagram to render. Wow. So they gave, in this particular project, a beautiful schematic diagram of all the interfacing components. Now, I don't want you to go into the Kabuki and talk about the microcontroller inside there and its memory and all that sort of stuff. We don't want to go to that level. But a block diagram, perhaps, of maybe the sensors and how they talk to the MCU on the Kabuki, something like that. That's fine. How the MyRio interfaces, you should know, perhaps now, the format, how it does that. It does it via UART, a serial port. And it looks good as an overview, right? Sets the scene so people reading the rest of the report know exactly how everything bolts together, but doesn't get stuck in the details about what happens inside the Kabuki. Don't really care too much about that, right? Sensor data is what's important. All right, so one thing I will highlight, referencing figures, right? So, here we go, wow. Why does that take so long to render? Anyway, all your figures should be labelled, captioned, and numbered, right? So figure 1 gives an explanation, and it should be done in the text. Never just put a figure in there and just assume that someone will look at it. If it's not mentioned in the text, I won't look at it, okay? That's a simple rule. They also have a lot of acronyms, so they actually had a list of abbreviations or acronyms early on. Okay. Footnotes, you can do footnotes if you really want, but referencing should all be included at the end. Okay, it's better to have references at the end than as footnotes. So we want referencing your chosen style. If you want to do it as numbers, if you want to do it as author's name and year, up to you. So APA, whatever, it's up to you. Just like Capstone, doesn't matter. We don't have a set referencing technique for that. Now, so going through this, it's a pretty big report. There were 4 people in the group, so they've got a massive report. So let's go through let's see if we can find some of the testing data in here. So here's some of the testing data here. They put some SPICE simulations down the bottom here to show validity of the thing working. Likewise, you don't have SPICE simulations to do, but you may be looking at a validation procedure based on an FSM design. Okay, so a pen and paper validation exercise. Right, what else did they have good in? So they had some CAD design. There's not really too much to pick on, to be honest with this. It's neatly formatted, nice spacing. It's like 1.5 space. It's easy to read. all of their figures are relevant. And one thing you'll notice is that there's no chunks of irrelevant code. That's one of the worst things you can do, to put in code, especially if you've done it in C. I don't want to see slabs of code. Oh yeah, here's main.c. Right, I'm not going to read that. If you've done it in C, draw it as maybe a flow chart or something like that. Maybe, but you've got the FSM diagram anyway to outline the algorithm. If you've got LabVIEW screenshots, do that as well. That's the implementation of your state machine. Here, this is in Altium or something like that, right? Schematic capture program. Okay, let's skim through. So they did some testing here. Let's skim through to the appendices. So all their appendices, look at this. This is all in appendices. In the appendices, how they set up the Simulink environment, right? Stuff that we don't really want to see, but we may need to refer to if we wanted to replicate the project. Okay, so all this rubbishy stuff, which is boring and takes away from the argument of the project, goes in the appendices. References. Oh, references are probably before here. So all their references, and they've got a ton of references. This is a good idea of the scale of a capstone project, 60 references. Yes?
In our report, I don't think we can provide any reference.
So I gave an example of if you wanted to motivate the project by why would you have an autonomous robot, go and reference some stuff, right? Reference some web pages that are out there. What? Yes, yeah, we expect you to have some, well, you should be referencing something, lecture slides or the textbook at the very least, right? Okay? Okay, so that's a good report. Let's have a look at something that's perhaps not so good. So and I'll highlight where people have gone wrong. So yeah, unfortunately there's not too much to say about that one because it was an H1 level report. Okay, I've got to remember which one's the bad ones. Could be this one. My comments might be on this one as well, so I have to be careful. Okay, so this is a not so good report. And these are my comments too, so you can get an insight into the marking of a capstone project. So this was one from a little while back, but basically, okay, great, they've got a table of contents, that's handy, but it didn't read very well. So they did follow my advice and have an introduction chapter, a background theory separate chapter. Okay, that's fair enough. Oops. Then a design and development chapter. That's kind of a results testing chapter. And then reflection, discussion, conclusion sort of thing. You'll see that there's not much difference with these page numbers here. So they kind of spent all their time doing this and then rushed testing, rushed discussion. So all in all, this is borderline pass, this one here. This is a prelim report as well, so they had the opportunity to fix things from here. Okay, so yeah, lots wrong here where they needed to sort of move stuff around all over the place. But in particular, what do we notice? Early on, lots of little sections. I mean, a section dedicated to router, which is one sentence. Okay, it doesn't read well when you are mentally breaking across topics here for one sentence and you're into another one, okay? Bullet lists would be better for that, or enumerated lists, something like that, right? Much nicer. It didn't read well. They started talking about the choice of devices way back in which chapter? Introduction. Whoa, you're still trying to motivate the project, right? Why you did this, and then you're talking about why you chose the devices. Okay, that's a design and development chapter, right? This should be very high level, talking about the project as a whole. So For instance, here, yeah, they're talking about router can be anything, but they went with the Raspberry Pi 2. They're locked into a particular hardware. Okay, what else is the problem? So once again, they're getting into too much detail here about particular hardware that was used, and I told them to move it to back to the chapter and to integrate this into chapter 1. Now, another thing, they probably... Yeah, so this group also did not ever reference Figure 1. I don't think I see Figure 1 ever mentioned in here. So it means it's just floating there. Yeah, it's there. The text should always back up your figures to say, look at it, go look at it. Okay, now we're going to talk about what's in the figure. Right, what else? Bullet points. Great to have bullet points here, right? If you've got reasons, don't have them as just a big slab of text. Bang, 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 bang. Reasons for doing something. Yeah, tables. Don't split tables over, I don't know if you have tables, but don't ever split them over pages. Page numbers are good. Please have page numbers on there. They did that well. Yeah, typical again, not referenced. And this is almost even superfluous anyway. Raspberry Pi 2 board. Okay, yeah, sure. I don't know what that's really telling me, but it's a picture of one, and they don't reference it. It's just like, it's just there. It's just there for looks. Okay, so I'll show you also now. They talk about, what do they do here? They're talking about how to install stuff on the Raspberry Pi via terminal commands. I mean, too much information. We don't want you going into great lengths about all the commands that you had to do to run stuff. Too much info. It gets worse. I'll skip forward. See, look, this picture, router used in the project. All right. No mention of what that router was, just a picture of it. So I'm going to have to zoom in and try and find that part number off there to work out what it is. Now, poor formatting again, sometimes using capitalised first letters, sometimes using all caps. It's just randomly changing like that. And again, this is Python code, I think here. Yeah, Python code. Slabs of Python code. That doesn't tell me anything really useful. If you want to show slabs of code, bits of code, just isolate them and perhaps argue why you're actually doing that. Here, look. Commands to update the operating system. That's irrelevant. Right. Let's look through where this report also had a major failing was in those last sections I was talking about. Again, bulleted stuff. Make sure it's bulleted. There's tons of code just inserted random. Look, this sort of stuff. You know, code doesn't help anyone. Now, get right through to the end. Is this an appendix? Oh, good, it is an appendix. Phew. Now, if we have a look, here is where a lot of stuff was... So this is all just going on about the design. Here's the performance section. Okay, some block diagrams. Oh, no, sorry, this is actually their web interface, if I remember, yep. And that's it. So there's no testing, okay? You won't make that problem. But discussion. That's it. 20% of your report mark is on what you reflect on. Here's, okay, current stage is a problem, whole design's open loop control, so therefore maybe we can close the loop on it. So all these problems, why don't you expand the system, why don't you use MoPD API, etc., autoconfig. This stuff is also great for thinking about crazy stuff, okay? What if do you want to propose a LiDAR system on the top of this, on top of the Kabuki? Propose it. What would it need? Is it cheap? Is it expensive? What sort of output data does LiDAR give you? Okay, interesting stuff like that. That's the cool bit. This is where you can just ramble on about stuff. It's pretty easy to do. Okay, their references are kind of okay. I don't know if they're sorted in the order. I don't know, order of appearance. And then at least they did put some code in the appendices. but it's all spaced weirdly and stuff. Right, so this is an example of a report that would be borderline pass. This is like a 50-ish, if you're lucky. The discussion section really hurt them majorly. Okay, I'll see if I've got one more that's in between. And I'll show you some different formatting as well. So quickly, just one more that's in between. Someone got a question? No? Let's pick. So this, I think this one's in between. This one's about an H2-ish, H3-ish, I think, if it's the right one I've got here. Right. They did it a little bit differently. This is a guitar-playing robot one. They did it a little bit differently. They had an introduction, then they broke it down into its subcomponents as a design and development here, and they talked about problems and solutions. So in each section, personally, I wouldn't do it this way, but they thought it was the best way to break it down into component and then go through all the design and everything of those bits. I think because that's how the group did their work. They kind of all separated and did bit things individually. It's a long report. Mind you, they had a decent reflection discussion section, which was good. That's what we like to see. Some nice pictures of the hardware and stuff. This is a pre-existing one out there, right? But at least put some pictures of what you did in there. It makes the report look a little nicer, and reference it. Show that this was testing in some particular workshop on some particular date, whatever. Nice block diagrams of stuff. Note that there should be no code. If we're skimming through this report, there's no code anywhere in here, right? It's just all pictures of what components they used, how they're interfaced, and how they tested it. There is no code. We don't like seeing code. And if they actually, this is their final report. In their prelim, they actually had code for all of this, C code, I think, for all of this stuff in here. And I said, replace it with the flowchart to show. It's much cleaner to show it as a flowchart. Let's just skim to the end. They broke the further improvements down according to their modules again, talking about the graphical interface, issues with the Bluetooth comms. If you've got issues with the project, or you had problems, put them in here. Just let loose, right? Don't talk about the weekend workshop sessions, though. You can complain about that to me. And sort of a one-pager conclusion is reasonable enough. Okay, so that's it. 20 pages will be consumed pretty quickly by pictures, data, that sort of thing. So I don't expect 20 pages to be such a killer for you. Yeah, question?
Do you need to include the cover page in the beginning?
Cover page is the page count. If you have a title page, yes, yeah, include that, yes. Yep. Now, lastly, what we will be getting you to do is also getting you to submit a contribution statement, okay? Very similar to the capstone report, and I haven't put it up yet because obviously you haven't submitted a report yet, but it requires each of you to write who did what in the project, all right? That's just another way of testing whether or not everyone's contributed equally. If there are cases where people disagree on what they contributed, then we will then work things out accordingly. Okay, so if one person said, I did everything in the project, or two people and one person did nothing, then we essentially call you in and speak to you and work out where to go from there. Okay. If you worked all together and all happy, you'll get the same mark. Okay? It's only rare cases that actually happens. So, all right. Okay, I'll leave it there because I'm about to die. So, next lecture. So over the weekend, while I was sick and lying on the couch with my laptop, I wrote a practice exam for you. We will go through the practice exam on Wednesday, and I'll talk about the real exam and summarise the subject. And I have to check my practice exam because I was delirious when I wrote it, so I have to make sure it's okay. All right, and I'll see you on Wednesday.